So this final example from lesson 2 of related rates comes from an assignment question that you will find in your textbook, specifically question 8 on page 145. So one thing I should say is when I looked at the answers in the back, I noticed that there is an error in the answer, and so I'll show you how to do this correctly, and hopefully you'll be able to do questions like this in the future and get the correct answer. So again, we are coming at this from a geometric perspective where we're looking at an equilateral triangle, and the length of the side is decreasing at a rate of 2 centimeters per minute. And the question is at what rate is the area decreasing when the area is 10 square centimeters? Okay, so let's start with a diagram. So we've got an equilateral triangle. I'll try to make this look kind of equilateral-ish. Okay, and actually I could probably go with a bigger one. Okay, and so here's what we need to do. We need to figure out the two quantities that are being related to each other in this question. And it looks like it has to do with the length of the side as well as the area. So I need to have some kind of formula. Like if I call one side x, then all the sides are x. And I really need some kind of formula for the area of this triangle in terms of x, right? Without introducing any other sorts of variables. Okay, so to do that then, I need to resort to the area formula for a triangle. And so let's do this. Let's come up with a, yellow is not the greatest color, is it? Let's change that color to something that is noticeable. So maybe something like that. There we go. So anyways, I was saying the area formula of a triangle, well, how does it start? I guess it starts like this. Area is equal to half base times height, okay? So far I've got area is equal to half, the base is x, and then the height, I need the height to be written in terms of x. So I think what I'll do is work with the diagram that I have here. I'll erase that x and I'll just put half x here and half x there. And then if I just focus on this triangle, this right triangle right here on this side, right? I could pick a side. I'll just pick the right-hand side. This is my h right there. And so what I have is I've got the hypotenuse as x, the base is 0.5x. I should be able to describe the height in terms of x as well. So I'm going to put this on pause for now. And maybe over here I'll say 0.5x squared plus height squared is equal to x squared, right? That's just Pythagorean theorem. Base squared plus height squared equals hypotenuse squared. So I've got 0.25x squared plus h squared equals x squared. H squared then would be equal to, if I subtract 0.25x squared from both sides, this is actually 1x squared. 1 minus 0.25 is 0.75x squared. Okay, and I kind of got on a roll here with the decimals. I probably should have gone with fractions, but that's okay. So if I square root, then I'll get h is equal to, this would be like square rooting 3/4 x squared, right? So really, h is equal to root 3 over 2x, right? If I square root each of the elements inside or underneath the radical, I get square root 3, square root 4, which is 2, square root x squared, which is x. So that's the height. Okay, so I think I'm good then. So then the area of this triangle in terms of x would be equal to half base, which is 0.5 x, right? So half base times height. Height is root 3 over 2 x, half base times height. There you go. Oh, but wait a minute. That's only the area of this side of the triangle. So I really should double that, right? I really should double it because there's the other side. Well, that's fortunate because the 2 and the half cancel each other out. Okay, so I end up with an area formula. If I clean this up, going back to the original color, area in terms of x is actually equal to, it looks like it's going to be root 3. This is half times half, which would be 1/4. x squared. So I think now the hardest part is done, right? Now what we need to do is figure out the related rates equation. So the rate of change of the area with respect to time is equal to the derivative of the other side, right? So this would be 2 comes down, so I'd have 2 times root 3 over 4x dx dt. Okay, and so now I'm ready to use this. I do need to find out one other piece of information. I do need to know what the value of x is at the very moment that they would like me to figure out the rate of the change of area. So it does tell me that at this very moment in time, the area is 10 square centimeters. So I can use this formula for the area of the triangle and figure out what the x value would be when the area is 10 square centimeters. So sub in 10 for A and solve for x. Okay, so sorry, this might get a little bit messy here, so I'll just box this off for now. So from here, I'm going to get 40 over root 3 equals x squared. And then I'll get 40 over root 3 square rooted equals x squared. So I've got like, equals x. So I've got the square root of a square root inside. So 40 divided by, just on my calculator right now, 40 divided by root 3 is equal to 23.09. We'll square root that, and I get 4.81. Okay, and I'll be sure to use the exact value as I carry it over into the other equation. So dA dt is equal to, I guess we can simplify this. So this would be root 3 over 2 times 4.81 times the rate of change of the length of one side. Now it's decreasing at a rate of 2 centimeters per minute. So I'm going to go minus 2. And that should be my answer. So I'll take the exact value of the 4.81, multiply that by negative 2, multiply that by root 3 over 2, and I end up with negative 8.32. And that would be centimeters per minute. Oh, and I should probably say square centimeters per minute. And I guess one last comment. This actually, I think this actually doesn't match up with the answer at the back of the book, because I just noticed this now, but this one says 10 square centimeters, and I believe the question in the book is actually 100 square centimeters. Nevertheless, having said that, here's 2 things to keep in mind. We've got the correct answer right here. This is different from the book, okay? But one last thing is the answer in the book for question number 8 is still wrong. Okay, it's not the right answer. So I would encourage you to try the one in the back of the book. And I believe the answer is should be around 26. I'm just going to verify that. Let me just double check here. Sorry to make this video run long. Yeah, it should be about 26.3 square centimeters per minute. So give that a shot, and we'll see what happens. Okay.